Alright, next we're going to look at equilibrium. Static equilibrium is when you have something hanging, like a sign, are the examples we're going to look at the most. The key is, these are easier because your acceleration is 0. So these are usually tensions. They're not the same as the length of them, it's how much force there is in that string. And if these are at angles, we'll call them theta 1 and theta 2. So if we draw the free body diagram, we've always got weight down, we've got T2 going this way and T1 going that way. Now we can separate these into components. This one is opposite, so it's T1 sine. Opposite is the sine one. This one is adjacent, so it's the cosine. This is your angle, so the opposite one is over here, T1 sine. And the cosine one is there. So let's look at what forces we have going up and down. We've got this one going up, and this one going up, and this one going down. So you take T1 sine of theta 1 plus T1 2, which should be 2 sine of theta 2 minus mg equals ma, but your acceleration is 0. So that's up and down. And then right and left, you can pick right or left, doesn't matter which one, so I'm just going to pick right since this might go to positive, minus T1 cosine of theta equals 0 because it's not accelerating. So then you have two equations and two unknowns. You're going to want to rearrange this one. It's easier for one of the tensions, either T1 or T2. You're usually not given both of them, you're usually solving for them both. And you plug this in for T2. I'm going to move the mg to the other side. So then at this point it really helps to have some numbers, although you can see that this is tangent because it's sine over cosine. So it helps you a little bit because it'd be cosine of angle 1 times tangent of angle 2. Then once you have T1, you'll solve for T1 there. Then you plug that back in over here so you can solve for T2. So that's if you have like two at an angle. If you just had one at an angle and the other one was flat, like held on over here to the wall, and then one at some sort of angle, you would do the same thing where you just look at, here's my forces, let's call that T1, we'll call that one T2. You separate this one into components, and then you just would do, so up and down you've just got T2 sine of theta minus the weight equals 0. And side to side you've got T1 minus T2 cosine of theta equals 0. It's just another variation. You just separate things that are at angles and consider up minus down and right minus left. And these ones, they always equal 0 because it's static, so it's not moving. So your acceleration is 0.